There's a video circulating right now that has genuinely rattled some of the smartest people in the battery industry. Not because it's obviously fake, but because parts of it are real, and that's what makes this so hard to dismiss, and so dangerous to believe without question. A company called Donut Lab released footage of a solid-state battery charging to full in under 5 minutes. The comments exploded. Forums lit up. People started saying things like, "Toyota is finished, and this changes everything." And honestly, watching the video, you understand why. It looks convincing. It sounds convincing. A credible European testing lab appears to back it up. But here's what nobody is telling you. The one thing that was actually verified is not the thing being celebrated. Let's go back to the beginning, because the setup matters here. Donut Lab is a startup, registered in Estonia. At the time of their announcement, they had roughly 9 employees, not 9 battery engineers. 9 people total, most of them in sales, marketing, and startup operations. One member of the team has a background directly related to battery technology. And yet their claims don't read like a cautious startup finding its footing. They read like a company announcing it has solved every single problem the battery industry has been fighting for 30 years. Simultaneously, 400 watt-hours per kilogram energy density, 100,000 full charge cycles, 5-minute full charges, no active cooling required, no cobalt, no nickel, ready for mass production. Each of those claims on its own would be a headline. Together, they represent something that companies like Toyota, Samsung, and CATL organizations with thousands of PhD researchers and billions in R&D have not come close to delivering, not even close. So the question isn't whether this battery is impressive. The question is something much more uncomfortable. Which parts are real, and which parts are being used to make everything else seem real? This is where it gets genuinely interesting. Because Donut Lab didn't just publish a press release and disappear. They brought in VTT, a highly respected Finnish technical research center, to run an independent evaluation. And VTT published results. Real results. Results that show an 11C charging rate. A full charge in roughly 5 to 6 minutes. 80% in under 10 minutes. Those numbers are extraordinary. For context, the fastest lithium-ion EV batteries available today, best in class. Ideal conditions top out around 5 to 6C. And it held up under testing. So yes, the charging speed appears to be real. But here's what the VTT report actually covered, and what it did in single quotes. TIDT tested a single cell. In a laboratory environment, they did not verify the electrolyte. They did not open the cell. No puncture test, no nail penetration, no thermal compression, no simulation of what happens when that cell sits inside a battery pack surrounded by thousands of identical cells, all generating heat at the same time. The presenter of the test acknowledged this directly. This was not a Pacluval evaluation. It was a single-cell evaluation under controlled conditions. That distinction is everything. And most of the coverage buried it or missed it entirely. Now, here's the moment in this story where things stop being ambiguous and start being genuinely concerning. During testing, the battery was pushed to 11C with different cooling configurations. When a second cooling plate was removed, meaning less cooling, not more, the battery actually performed better. It charged faster. It sustained higher current longer. It reached full charge about a minute quicker than with full cooling applied. The reason is technically straightforward. Higher temperatures, lower internal resistance. Lower resistance means current flows more easily. So yes, letting the battery run hotter made the charging metrics look better, but the single cell reached 192 degrees Fahrenheit during that test. Donut Lab had marketed this battery as not requiring active cooling, and technically, it didn't explode. But 192 degrees Fahrenheit from one cell, in a controlled lab with airflow and monitoring equipment, is not the same as what happens when you scale that up. Imagine 10,000 cells, packed tightly inside a sealed battery enclosure, each one generating that level of heat simultaneously. Without a serious thermal management system, in a vehicle doing highway speeds on a summer afternoon, the temperature would not stop at 192 degrees. It would compound, and that is not a theoretical concern. That is basic thermal physics. The fastest charging EVs on the market. Today, vehicles built by companies with decades of engineering experience all use sophisticated liquid cooling systems. Because heat is not a side effect of fast charging. Heat is the primary enemy of every battery ever made. Managing it isn't optional. It's the entire engineering challenge. Not Honda, not a single Tier 1 automotive supplier with the engineering infrastructure to conduct serious technical due diligence. A small motorcycle company. Major automakers have battery acquisition teams. They run continuous surveillance on promising technologies. If a startup with 9 employees had genuinely cracked the 100,000 cycle problem and 400 watts per kilogram simultaneously, those teams would have been in Estonia within weeks. The choice of Verge as a launch partner isn't proof of anything on its own, but it fits a pattern. The shifted commercialization timeline from within months, in early February, to by end of year, in the most recent confirmation, the absence of any manufacturing partner or pilot production line, the company homepage now visibly flooded with skeptical comments, left unaddressed. Here's where the story lands, and why it refuses to resolve cleanly. The charging speed is real. One verified metric, from one credible lab, under controlled single-cell conditions. That's not nothing. A genuinely fast-charging solid-state cell is a meaningful thing, even if every other claim around it remains unsubstantiated, but a company with one battery expert on staff has built a public narrative around 6 headline claims. One has been partially verified. The other 5, cycle life, energy density, thermal management, manufacturing readiness, and commercial scalability remain either unproven, internally inconsistent, or in direct conflict with established physics. That gap between what was verified and what was claimed is not a minor communications issue. It's the entire story, and the question that nobody can answer yet. Not the researchers, not the forums, not the analysts who've spent careers in this industry, is whether Donut Lab has a real technology that's being dramatically oversold, or whether the verified charging result is being used to make everything else feel credible by proximity. One gives you a promising, the startup that got ahead of itself. The other gives you something very different. The full independent audit hasn't happened yet. The cycle life data hasn't been published. The manufacturing partner hasn't been named. And a 9-person company is still asking the world to believe it solved what 30 years of serious science couldn't. What happens when someone finally opens that cell is the question nobody's talking about yet, but before we get there, let's talk about what opening the cell actually means. Because this is where the story shifts from business skepticism into something that touches the foundations of how scientific trust is built. And broken dot in the battery industry. There is a standard set of tests that any serious manufacturer must pass before the words ready for commercialization are allowed anywhere near a press release. Nail penetration, thermal compression, overcharge simulation, short-circuit exposure, drop testing. These aren't optional extras. They're the baseline. They exist because batteries store enormous amounts of energy in very small spaces. And when that energy releases uncontrolled, people die. VTT, single quotes as evaluation, credible as the institution is, did none of those things. They tested charging speed. That's it. And even that was done on a single cell, isolated in a laboratory, under conditions that were explicitly described as not representative of real-world pack integration. So when Donut Lab's video circulated, and commentators said it's been independently verified, they were technically correct and fundamentally misleading at the same time. Verified for one metric, one cell, one lab environment. Not verified for safety. Not verified for longevity. Not verified for scalability. Not verified for the conditions that actually determine whether a battery can live inside a vehicle being driven by a human being at speed. This matters because trust in battery technology isn't just commercial, it's physical. The reason the industry runs those brutal stress tests isn't bureaucratic caution. It's because the alternative is a vehicle fire on a highway, or a phone in someone's pocket, or a warehouse full of energy storage units that decides to become a very large, very fast problem. Skipping those tests and calling something verified is like publishing the first chapter of a study and announcing the conclusions. And this connects to something deeper that the online conversation around Donut Lab keeps circling. Without quite landing on, there's a version of the story where everything Donut Lab claims is Directionally true, the chemistry works. The architecture is sound, the potential is real, but the company got so far ahead of its evidence that it created a credibility hole it may never fully climb out of. Startups do this, especially deep tech startups, where the gap between we have something real there and we can prove it at scale opening the cell actually means. Because this is where the story shifts from business skepticism into something that touches the foundations of how scientific trust is built and broken. In the battery industry, there is a standard set of tests that any serious manufacturer must pass before the words "ready for commercialization" are allowed anywhere near a press release. Nail penetration, thermal compression, overcharge simulation, short circuit exposure, drop testing. These aren't optional extras. They're the baseline. They exist because batteries store enormous amounts of energy in very small spaces, and when that energy releases uncontrolled, people die. VTT, single quotes as evaluation credible as the institution is, did none of those things. They tested charging speed. That's it. And even that was done on a single cell, isolated in a laboratory, under conditions that were explicitly described as not representative of real-world pack integration. So when Donut Labs' video circulated, and commentators said it's been independently verified, they were technically correct and fundamentally misleading at the same time. Verified for one metric, one cell, one lab environment, not verified for safety, not verified for longevity, not verified for scalability, not verified for the conditions that actually determine whether a battery can live inside a vehicle being driven by a human being at speed. This matters because trust in battery technology isn't just commercial, it's physical. The reason the industry runs those brutal stress tests isn't bureaucratic caution. It's because the alternative is a vehicle fire on a highway, or a phone in someone's pocket, or a warehouse full of energy storage units that decides to become a very large, very fast problem. Skipping those tests and calling something verified is like publishing the first chapter of a study and announcing the conclusions. And this connects to something deeper that the online conversation around Donut Lab keeps circling, without quite landing on. There's a version of this story where everything Donut Lab claims is directionally true. The chemistry works. The architecture is sound. The potential is real. But the company got so far ahead of its evidence that it created a credibility hole it may never fully climb out of. Startups do this, especially deep tech startups, where the gap between we have something real and we can prove it at scale can span years and cost hundreds of millions of dollars. The temptation to collapse that gap in public communications to let the demo stand in for the roadmap is enormous, especially when you're trying to attract investors, partners, and press attention simultaneously. But there's also a version of this story that's less charitable, and the details stacked together make it harder to dismiss. 9 employees, 1 with a technical battery background, no disclosed electrolyte chemistry, no peer-reviewed publication, no manufacturing partner, a commercialization timeline that already slipped, a launch partner chosen from the narrowest possible slice of the market, and a homepage that looks, right now, like a comment section at war with itself, with accusations of fraud sitting publicly beneath the company's own branding. Unaddressed, that combination of signals doesn't prove wrongdoing. But it doesn't look like a company that's quietly confident in its technology either. Companies that have genuinely solved hard problems tend to invite scrutiny. They publish the data. They open the cells. They invite the skeptics in because they know what's inside. Donut Lab has not done that. Not yet. And the longer that window stays closed, the more the narrative around them calcifies in a direction they cannot control. Let's zoom out for a moment, because Donut Lab doesn't exist in isolation. They exist inside a much larger story about what the world desperately wants from battery technology and how that desperation shapes what we're willing to believe. The electric vehicle industry is at an inflection point. Range anxiety is real. Charging infrastructure is genuinely inadequate in most of the world. The environmental pressure to accelerate the transition away from combustion engines is building from every direction, and the battery, the single most critical component in all of it, remains the primary bottleneck. So when a video appears showing a full charge in 5 minutes, the emotional response isn't just excitement, it's relief. It's the feeling that maybe the hard part is over, that someone, somewhere, figured it out. That emotional need is not irrational, but it is exploitable, and the history of the energy sector is littered with companies that understood this, that knew a compelling demo at the right moment could generate enormous momentum before the technical reality had time to catch up. Theranos wasn't a battery company, but the structural pattern, a charismatic founding narrative, a compelling early result. Selective disclosure, high-profile partnerships used as credibility proxies, and a community of supporters emotionally invested in the promise. Is a pattern worth knowing that comparison is not an accusation. It is a warning about the shape of a story. And right now, the shape of Donut Lab's story has some features that resemble it. Here's the thing about the 100,000 cycle claim that hasn't been said clearly enough. It's not just scientifically implied, it's strategically strange. If you are a legitimate battery company and you have genuine data showing 100,000 cycles, even partial data, even early cycle curves showing a trajectory, that could plausibly extrapolate. There, you publish it immediately, because that data would be the single most valuable piece of intellectual property in the energy sector. It would attract serious capital, serious partners, and serious protection in the form of patents and licensing agreements. The fact that no such data exists publicly, not a cycle curve, not a degradation graph, not a partial data set with a methodology note, is not a communications oversight. It is either evidence that the data doesn't exist, or evidence that the company doesn't understand how transformative it would be to release it. Neither of those possibilities reflects well on the claim, and the cycle life number matters enormously beyond the technical argument, because 100,000 cycles, if real, doesn't just improve electric vehicles. It restructures the entire economics of energy storage. Grid-scale storage becomes viable at a completely different cost curve. The business model for vehicle manufacturers changes fundamentally. Insurance, warranty, resale value, every downstream assumption in the EV industry gets rebuilt around a battery that effectively never dies. A claim that large demands evidence that large, and the evidence isn't there. So where does that leave us? Not with a verdict. That's the honest answer, and it's the answer that the loudest voices on both sides of this debate don't want to give you. The people calling Donut Lab a complete fraud are extrapolating beyond what the evidence shows. The charging speed result is real. The VTT institution is credible. Something is happening inside those cells that produces genuinely fast ion movement. That's not nothing. The people calling this the most important battery announcement in decades are doing something more dangerous. They're treating one verified metric as confirmation of 6 unverified ones. They're letting the emotional logic of the story, small underdog beats the giants, override the technical logic of the evidence. The truth, right now, sits in an uncomfortable middle space. A real result, surrounded by unverifiable claims, from a company that has not yet shown the willingness or the ability to open the door to the level of scrutiny that claims this large require. And here's the question that should actually be keeping you up at night, not whether the battery is real, but what it means that we want it to be real so badly that we stopped asking the hard questions before the answers existed. The battery industry has a credibility problem that predates Donut Lab by years. Announcements cycle through the news with language like breakthrough and game-changing and ready for commercialization, and then quietly disappear when the engineering reality reasserts itself. Readers, viewers, investors, all of us have been trained to respond to that language with excitement first and skepticism second, if at all. Donut Lab didn't create that dynamic, but they may be benefiting from it, or they may be about to be destroyed by it. Both outcomes are possible from exactly where they are standing right now. The full independent evaluation hasn't happened. The cells haven't been opened by a neutral party with full access and no NDA. The cycle life data hasn't been published. The electrolyte hasn't been disclosed. The manufacturing partner hasn't been named. Every one of those things could happen tomorrow. And if they do, if the data is real, if the chemistry holds, if the cycle curves look anything like what's been claimed, then this will genuinely be the most important battery announcement in a generation. And the skeptics, including this analysis, will owe Donut Lab an enormous correction. But if those things don't happen, if the timeline keeps slipping, if the questions keep going unanswered, if the data never arrives, then the most important question won't be about the battery at all. It'll be about why we believed it before we saw the proof, and what that says about how we make decisions in a world that is desperate for good news and increasingly willing to trade evidence for hope.